Hello to my viewers around the globe. I'm Musa Yusuf Buhari. Welcome back to another new exciting episode of my program. So in this video, I'm going to explain how to calculate the energy yield during beta oxidation of the fatty acid. And to do that is very simple. All you need to do is to look at how many carbon atom does the fatty acid you're trying to calculate the energy yield during the beta oxidation, and to also know how many acetyl CoA does it produce when it is being completely oxidized through the beta oxidation process, and to also know how many reducing equivalent you have or you obtain. To do this is very easy. I picked palmitic acid as the case study to consider the beta oxidation process of the palmitic acid. Palmitic acid is a 16 carbon fatty acid. So if you look at the structure of the palmitic acid, you tend to understand the calculation of the energy yield. Of course, this is 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then this is the 16th position of the palmitic acid, where the CH3 or the R group ended. Now, this is a common rough sketch of the palmitic acid. This is the carboxylic functional group, and then this is the methyl N, which is the omega uh, carbon of it. Now, from this, to calculate the energy yield, the first thing to do is to know how many carbon atoms does it have. For the palmitic acid, and the number of carbon atom is 16 carbon atom. It is a 16 carbon atom fatty acid. Then the next thing is to know how many oxidation reaction does it take. It is through the number of the cycle of the oxidation reaction you tend to obtain how many acetyl CoA. The number of the oxidation reaction in the process determine the number of the acetyl CoA produced in the reactions. So now to do this is very simple. All you need to do is to divide n by 2. Then you now have 16 all over 2, and 16 over 2 is 8. So now we have 8 cycle of reactions that palmitic acid will go to completely oxidize through the beta oxidation process, and in this 8 cycle it produces 8 number of the acetyl CoA, because the number of the reaction cycle determine the number of the acetyl CoA so produced. So in the beta oxidation of the palmitic acid cycle, we have 8 numbers of the acetyl CoA produced. Then to know the number of the reducing equivalent produced, you divide n all over 2 minus 1. This can give you 16 divided by 2 minus 1. And 16 over 2 is 8. 8 minus 1 is 7. So now, since there are two types of the reducing equivalent, you have the first one, the NADH2. The NADH rather is 7 NADH molecule produced during the beta oxidation. And for the flavonoid adenine dinucleotide, it produces also 7 number of that reducing equivalent. So now to calculate the number of energy is to multiply by the ATP so produced by the molecule of the substrate. Now for the acetyl CoA, it usually produces 10 ATP per 1 molecule. So now 8 molecule of the acetyl CoA so produced times the 10 ATP that is usually produced, you now have 8 times 10, which is 80 ATP that is being generated during complete oxidation process of the beta oxidation of the palmitic acid. And then for the reducing equivalent of NADH, you now multiply times one amount or one molecule of NADH usually produce 3 ATP. So you now multiply 7 times 3, you now get 21 ATP. And for FADH2, one molecule of FADH usually produces 2 ATP. So therefore, you now multiply 7 times 2 ATP, then you now have 14 ATP that is being produced during this process. So now you just do simple arithmetic to obtain the total or gross number of the ATP produced. So you now add the 80 ATP from the acetyl CoA, then plus the 21 ATP from the NADH, plus the 14 ATP from the flavonoid adenine dinucleotide. Then when you sum up together, you will now have 80 plus 21 plus 14, of course, is 115 ATP as the gross ATP so produced. And for the total net ATP produced, net ATP generated, so you remember that during the kickstarting of the process of the beta oxidation, in the first reaction to activate the fatty acid into the fatty acyl CoA, it requires 2 ATP. So you have to subtract the 2 ATP that is being required from the initial process of the fatty acid reactions. So now when you minus 2 ATP from the 115, you arrive at 113 ATP that is being generated during beta oxidation of the fatty acid. So thank you. I'm Musa Buhari Yusuf.